Repeaters can be used to further extend a pulse that is going inside of it. So you can see that we have a power of 15 going into it, and the redstone repeater takes in a power of 13, but all it does is just it extends it, and now you have a power of 15. You can also use it to delay a signal. If we had the power source and set it to tick of 4 delays, it powers this piston 4 ticks later. Now we also know that we can use it to power a block itself, which transmits the signal. Hence how you can turn off a redstone torch. Now we can use this inverter mechanic to create our simple piston doors. This piston will always be powered because of this redstone torch, and we're combining the logic that we're transmitting blocks to power just one piston. We're actually powering both pistons. And of course we have this inverter set up, so we have a repeater running through, and when we step on the pressure plate, it unpowers this piston over here. Now you can make an infinite clock just by using redstone repeaters, simply by powering it on, and turning off that power source will constantly make it powered. And if you replace the redstone by breaking it and placing it back in, it would actually create this kind of clock. So you can use it to constantly power things on and off. Now you can use repeaters to make some sort of a pulse extender. For example, if we have a repeater feeding into this solid block here, and we have repeaters going in a loop feeding into the same block here, and we set them all to 4 tick delays, when we do power on this button, this repeater will power this block, of course being able to power on this redstone lamp. And since we have these repeaters going in a loop, again powering on this block, will allow you to have the extension of the pulse. So if we do turn it on, we can see that the redstone lamp is on longer usually than it would have been if we didn't use the pulse extender. So this is how long it stays on with the pulse extender, and this is how long it stays on without the pulse extender. Now an interesting mechanic about redstone repeaters is that you can use itself to lock a different repeater. So if for example we have a redstone torch flowing into this redstone lamp, which constantly powers it on. But what if we wanted to power it on if we didn't want this redstone repeater here? So what we could do is set up a different repeater, and once we power this repeater into this repeater, it completely locks the signal. So now if we take off this power source, this will constantly be on. And if we were to remove this original power source, the entire circuit will turn off. And you can see that because if this wasn't powered off initially, regardless of if we powered this on or not, this redstone repeater is locked to its original signal, which means it will be constantly off, regardless of if we power it on now. Now this mechanic is very confusing, but you can use it in some cases. For example, if you wanted to make a falling edge clock, you can create this contraption in which this lever powers both this repeater and this redstone. This redstone powers this repeater, which entirely locks this repeater here. And because this repeater has a power signal transmitting into this block out of this repeater, it actually gives off a signal into the redstone lamp. So when we turn it on, we can see all of this in action. Now, because this is locked, regardless of this having a power signal or not, does not matter. Now, when we do turn it off, this redstone repeater also turns off, and this repeater will unlock itself. And there's a slight delay because this repeater is still powered on for a very small tick, and because it's powered on for a very small tick, it will actually power on this repeater here, allowing this redstone lamp to turn on. As you can see, the entire contraption is off, and there was a slight second that this repeater was on. Even though it was turned off by this, there was a slight delay, which caused this repeater to power on after it being unlocked, which powers on the lamp in turn. Now the reason why a falling edge becomes a bit redundant is because you'd have to power it on twice. So one state is it being on, and then turning off the circuit causes the redstone lamp to power on. A much more useful case is a rising edge monostable circuit, in which we have this contraption here, where we have the redstone torches constantly powering on this repeater here, which in turn locks this repeater. And of course, this redstone torch powers this repeater, which powers this block, and it transmits the signal into this repeater. So when this contraption is on, of course, these will act as inverters, turning off these both repeaters. And because there's a slight delay, this repeater will remain on for a very small amount of ticks, which will be able to pass on the redstone signal when this repeater unlocks, causing this redstone lamp to power on. So we can see it in action. And this becomes much more of a useful circuit because we only had to turn on this lever. But again, this becomes a bit more difficult because if the state is on, we'd have to turn it off and then turn it on again. So you're probably better off using varied power sources, such as maybe a pressure plate or a button, which turns off and on without you having to cause multiple inputs. So we can use this button as an example. If we were to power it on, it completely turns on this redstone lamp, and the button goes back to its off state. So you only need to give in one input again. Now this can be done on a falling edge circuit, replacing it with a button, but you can see that the behavior is a bit abnormal. So the fact that we turn it on won't cause the redstone lamp to turn on, but it would only turn on once the button goes back to its off state, which is a bit unpredictable because the button has a slight delay whilst causing the input. So you can see that the lamp only powers on once the button is going back to its original state.